Okay. Today we're going to start with our experiment number 9, which is circular motion. So the formula for the circular motion is the centripetal force that is required to an object to move in a circle is mv square divided by r. So if you see this, the force is directly proportional to the v square. And if we compare with this the straight line equation, which is mx plus c, if c is 0, so y is equals to mx. So if you compare these two equations, this and this, so your slope, which is m, is equals to m over r. So we're going to calculate this slope from the plot of f v square r. So you get a straight line and your slope will give you the m over r ratio. So how will we get from the experiment? We start with it, and for here we have this, so we have to add another column, which is new column, and we get the column name is velocity, velocity, and we're going to take a square of it and superscript square. We take the name v, it's the same case, subscript square squared, and then unit is meter per second, meter similarly 1 meter per second. So now with the expression we're going to select the variable. So variable is velocity, and then we multiply it by making a star, and then again select the velocity. So when you've done, you see this, a column is added. Now if you go to the next page, this is force versus velocity. We need to make it a velocity square. So we are going to plot the velocity square. So what we're going to do here, the experiment, we have a shaft and we have a force sensor into it. So the mass in this each shaft is 300 grams. So what we're going to do, we're going to set it at 10 centimeter, which is 0.1 meter, and we're going to change it this mass and make it, and we can change it like this. So see this, if it's moving, so we make it at 10 centimeters. Okay, so now the masses is 300 gram on both sides, and the radius, which is from the center, is 0.1 meters, 0.1 meter on both sides. So now this motion sensor will detect the motion. So what we're going to do, if you see this, you go to the first page, you are measuring the force, and if we change it, this sensor, we're going to go to experiment, set up all sensor. So here is a sensor, and you make it sensor. Your sensor is not working. Yeah, it's working now. Selected column. So what was the velocity?
Velocity square.
Velocity squared, which is coming from here, and then v, and then again and then unit is ms minus velocity unit is -1, and we select the variables, velocity, and then steric, then variable velocity, so it will become velocity square, and that column is added now. So when you add the column and go to the next page, you will see a force interpolated with a velocity. Now we have velocity squared, so we're going to plot it with a velocity square. So our radius is 0.1 centimeter. So we're going to change over here with this 0.1. We fix it, this is fixed and this is moving. And this moves with this force sensor. So change it at 10 centimeter. So now the mass is 300 gram on both sides and the radius is 10 centimeter. Now if we move it on the first page, so you see the force value now. So we can make it at 0. Go to the experiment, set up all sensor, show all interface, we make it 0. So we make it 0 now. So this is now 0. And what we're going to do, we're going to move it now. See this over here, the force is increasing as we are moving. And as it reaches to the 10 Newton, we're going to move it fast. Move it as fast. Yeah, so move it at 10 and it's going 10 and now I collect the reading. So now I am collecting the reading. So okay, so now this is collected. So this is our first reading. So if we move to the next page, we will get a graph like this. This graph should be a straight line, but due to the vibrations, it's coming here. Okay, so what we're going to do, we're going to select a linear fit and this a slope. So whenever you get to the lab report, so this slope, so we make a trial 1, mass is 0.3 kilogram, radius is 0.1 and the slope we are getting 3.978. So the slope of experiment we get. Now how to get the slope for the theoretical you select any value, calculator. So you divide this. Do I have calculator? Give me the calculator. So here is your value for the any value you select. I select this one, 8.992 divided by 2.387. So I get 3.767. So how to get an error? Error is E minus T divided by T mod multiply by 100. So this will give you the error. So if I calculate the error, this is theoretical value minus the experimental value 3.978 divided by the theoretical value 3.767 multiply by 100. So I get 5.5% error, positive value, because this is negative. So this is no. So the next trial would be 0.2, third trial 0.1. So you change the mass over here, 100 gram, you change it. The distance will be same. And for the next part, which is second part, you change the radius, 0.09, 0.08, 0.07, 1, 2, 3. The mass will be the same. And how to change the radius? You will come over here. You change the radius over here, 0.9. You fix it. And then you change it by removing this. Yeah, this is 0.8. No, you need to move it again. Yeah, so it has to be stretched like this. Can you tight it? Yeah, tight it now. Very good. So everything is stretched. Now it's 8. No, it's 8. So we need to move it to 9. Yeah. So tight it now. So, okay, and do the same experiment. Okay, so whenever you do the reading, you go to the experiment and store the latest one. Okay, so it will store the latest one, and there are 2 pages, so this will come. Okay, so now your mass will be 300 gram every time for the second run, and the radius will change. So, and you have to change the radius over here as well. So it will become 0.9, 0.09. Okay, for the part 2. Okay, and do the same reading and get the slope, experimental and theoretical, and the same thing you will go. Okay, okay, good.